habitat type. Got the recording. So now we are up and we are recording. Thank you, Jane. But yeah, this graphic shows different forest successional stages from young forest. Again, we have on the bottom axis, we have time. And as you're going further right, it's more time has elapsed. So we're going from young forest to mature forest, and we're showing different birds. You know, we can think of these as maybe umbrella species or representatives of different communities of where we might find these birds inhabiting different areas. So, you know, off to the left, we have forest birds that like to inhabit younger forests. We have the American woodcock, the golden-winged warbler, one I mentioned earlier, and we have prairie warbler. You know, a lot of these birds will inhabit and especially will nest in these areas. So that's kind of the kicker is, you know, if we're really thinking about populations in flux or populations in decline even, we're thinking about how can we have these birds successfully reproduce while they're here, either on migration or even if they're endemic to North America, if they're staying here, because it's so vital that they're able to carry on their genetics to the next cohort. And equally off to the right, you know, we have black-throated blue warblers, we have wood thrush, and we have cerulean warblers where, you know, they're not nesting in young forest. They're not nesting in young forest like in a golden-winged warbler is. You know, they're nesting in more mature forests. So whenever I'm thinking about forest birds, how we can help sustain these populations or even turn things around and to improve their populations, I'm thinking about forest succession on a spectrum. I'm thinking what species is imperiled, right? What species needs our attention the most, or what groups of species need our attention the most. So I think it's important to note that so far, looking at this diagram, we've identified nesting, right? And we've identified these different habitat types, but it's important to note that these relationships between avian communities, different species, and different forests and different successional stages aren't static. While a species might prefer to nest in mature forest, it'll spend the latter part of its breeding cycle foraging in nearby young forest, right? So we know for a fact that what happens is something we refer to as patch trading, right? So on the far left, we have our infamous golden-winged warbler that was in the last slide. And again, we know that, you know, they are absolutely nesting. They have to have young forests to nest and successfully reproduce. But they're also utilizing mature forest. I mean, they nest in young forest, but we're finding, and different studies are pointing to this, that they're actually foraging. They're foraging, they're taking cover, and they're migrating and traversing through large swaths of older forest, of mature forest. And, you know, on the other end of the spectrum, again, from our previous slide, we have a wood thrush. And as I mentioned, a wood thrush, you know, they're going to nest. They want to reproduce in mature forest. But what science and different research is finding is that they too like to go into young forest patches where they can forage on Lepidoptera and they can forage on different fruiting shrubs and trees. They can take cover from different predators and be concealed, and that they just, you know, will sometimes choose to travel specifically through a young forest patch, especially you know, in this time of year in the fall, whenever they're migrating. So this phenomena is you know, ubiquitous in that we see it essentially everywhere. We see it across different species of forest birds. And, you know, again, it's the reason why, you know, I don't think I a lot of times teach anything specifically on a specific habitat type, because we're more so thinking about the implications of having a mosaic of different forest types on a landscape and how they're in juxtaposition to each other, right? So, you know, if I'm thinking about golden wing and at the same time I'm thinking about wood thrush, I want to think about having young forest habitat. but I want to have that mature forest habitat real close to it, right? So these two species can have everything that they need for their life cycles and everything that they need with the changing of the seasons. So that brings me, to my next point, because it is time now to narrow our focus down a little bit more onto young forest and how much of the Mid-Atlantic region is young forest. I think that's a very valid question, and I hope everybody in the audience is thinking about, well, how much young forest really is there? If we take a picture, this is northern Pennsylvania, and we think about, okay, if we're to look out, at a vantage point or something, a real nice place to stop and kind of look at the valley, how much young forest would we see on that landscape, and how much would we see from satellite? And the facts are this: it's many of the forests in the Mid-Atlantic region are mature and they're older in age. There are large swaths of continual forest cover that can cover areas and provide surprisingly low amounts of young forest habitat on the landscape. So again, if we're thinking about forest birds and we're thinking about, the large swath of forest birds, our job at Audubon Mid-Atlantic is to ensure, natural resource managers, landowners, and the public at large that they understand the importance of forest age diversity. And this often means creating young forest habitat if it's not on the landscape. You don't have to take my word for it. There was, the study was conducted in 2011, so it's a little bit dated at this point, and published in Biogeosciences, and it reviewed the forest age distribution of regions throughout North America, right? And I apologize here if this is a bit pixelated, but this is the best I could do copying the figure over. It was a very nice figure, and if it got a little pixelated, I apologize. But we can see the Northeast region here, and in the bottom, I'm going to blow this up in the next slide, but it has the states included, and you can see just visually before you even kind of dive in, to this data that there seems to be a little bit of a bottleneck towards the middle distribution of that age group, right? So I'm going to go ahead and focus in on it more. And again, sorry if that got pixelated, everyone, but this is looked better on the screen before this. But focusing on the Northeast, where we're talking about, and keeping in mind that this study was conducted 12 years ago, we can, with our imagination, take a lot of these different distributions. These are the years. This is 1 through 10. This is 10 through 20, and the whole way down to 130 years to 211. So go ahead and move that another decade, right? So if we're to take this distribution of 50 to 60 years, that now becomes 60 to 70 years, 60 to 70 becomes 70, 80, and so on. So, we can also, with our imagination, shift that distribution over, and we can think about what has happened with the years in the age group 1 through 10. We can see here that young forest really is not overly common on the landscape compared to a lot of these intermediate middle age stands that are in the 60 to 110 year range. I would bet that even after 10 years since the study has been conducted, that the 1 through 10, the young forest, it would probably look relatively similar to what it was during this time. So again, we can think of a majority of the forest in the region that we are focused on, the region that we are working in, being in that 60 to 70, to 110, 120-year-old age group. A distribution that, again, is largely centered around these ages. So, oh, yeah, sorry about that. So forgot I had a animation there. So again, focusing on the middle, you can see a lot of our forest age groups are within basically 4 decades, 5 decades of one another. Not a lot of diversity in the big scheme of things. And again, often young forest habitat has to be created. It's lacking on the mid-Atlantic landscape, so we could wait. We could wait for disturbances, right? We could wait for secondary succession to happen naturally, rather than that be a tornado, a wildfire, an ice storm, something to create these conditions that were there long before humans were impacting the landscape. But one could also argue that with the declines of the forest birds, this is a rather pertinent issue that needs our attention sooner rather than later. And if you believe in sustainable forestry and you believe in a lot of the research that goes in behind it, we can actually create this. We can create this on landscape, and we can do so with the objective of improving forest habitat, right? So this is exactly what this project was done. This project was done by myself, and it was actually done thinking about golden-winged warbler, leaving reserve trees that were great for mast, right? Good mast producers, leaving white oak, species that are going to have a lot of caterpillar communities for our insectivores, but primarily opening things up and seeing blue sky as well, because we want to create those understory conditions so those species can reproduce successfully. So I have, interesting enough, had, and maybe it shouldn't be interesting. I think that, sometimes I can get so fixated on what I'm doing, and it's like I know, where I'm thinking with things, but I've actually had folks ask me, does creating young forest habitat, doesn't that conflict with Audubon's climate goals? I mean, what are you doing? You're going through and you're cutting the forest. And after all, you had working land, you had water, but you also had climate on there. I mean, it's something that we want to think about. And I put this in here because recently there has been heightened interest, because the public has become more aware, or at least are starting to think about it more, about the fact that forests store and sequester atmospheric carbon dioxide. This has led many groups to refute cutting forests at all, whether it be for bird habitat or not. And it Audubon Mid-Atlantic in our forest program, I think that we walk the line in saying we propose a different approach, but it's also based off of science and what research is telling us about forests, what it's telling us about forest carbon, and what it's telling us about climate change. So I'm now going to take the last third of the presentation and kind of talk about this nexus that we're working on. And I think that, again, yeah, I think it's a great time to bring it up, and to continue to think about forest birds as we think about these different goals. First thing that I want to do is I want to parse out the difference between forest sequestration and forest storage of carbon. So if we, look at definitions of carbon storage. So when we're talking about carbon storage, we're talking about the amount of carbon that is retained in a carbon pool within the forest. So, if we pay close attention here to the graphs on the right, and where carbon is stored in different forests with different forest types, it is important to note that we are showing carbon stores here. These are stores, these are pools, these are not necessarily sequestration rates. So I'll come back to these figures on the right in a minute, but let's also define carbon sequestration. It's the process of removing carbon dioxide from the atmosphere for use in photosynthesis by vegetation, resulting in the maintenance and growth of plants and trees, and that carbon then is stored in both plants and then the soil that they grow in. So you can see here, and I don't know, what kind of forest types might be around you. I know that there's a lot of overlap between, Pennsylvania, Maryland, and West Virginia and their forest types, but in a northern hardwood forest, these forests are dominated a lot by sugar maple, red maple, tulip poplar, beech, stuff like that. You can actually see that there's a lot that's stored in the soil, right? So we got 36% here is soil organic, and then we have X amount, we have about 7% that's actually stored in the root system of the vegetation that lives there. We have the live above ground. That's the stem. That's the tree itself that you're seeing out in the forest. And then we also have deadwood, right? Trees that fall down, they decompose, right? They are releasing carbon as they decompose, but while they are still there and going through the decomposition process, that still does count as being stored for a certain amount of time. And then we also have leaf litter, right? So we have about roughly 14% of forest carbon stored in leaf litter in northern hardwoods. And if you wanted to take your time, you could see the difference between a northern hardwood forest, an oak pine forest, an oak hickory, and even a spruce fir forest. So, but this diagram, I think, does a great job of thinking about where our carbon stores are, because I think that a lot of the times the public might only be thinking about the live vegetation, the tree itself. And as we can see, the live above ground, regardless of what forest you're working in, that might be in our region, it never equals even half the carbon that's being stored in that forest ecosystem. And that's really something cool to look at and to think about, the different ways that a forest ecosystem is storing carbon. So when we think about carbon sequestration, so we talked about storage and we looked at some of those stores now. Now we're talking about how much atmospheric carbon dioxide is that forest bringing in. So when we talk about it, or we think about carbon sequestration, we're thinking about the act of an ecosystem pulling carbon dioxide out of the atmosphere and then storing it elsewhere as new molecular chains. We need to think of forest age class distributions and how we can influence this, right? So we just had all this talk about forest succession, different age groups and things like that. And now we can look at actual carbon sequestration rates. So as you can see here, the amount of carbon that gets fixed or sequestered in the soil. So we have soil sink here. That's actually letter B. My apologies, that got cut off. And the leaf litter, right? We can think about that. It changes very little over the time span of a forest ecosystem throughout succession, right? So we can see here, from a forest that's age 0, right? This axis is forest age, 0 to 200 years. The amount of carbon that is being sequestered is very little in that sink, and kind of the same for soil, right? But we can see that it's linear with soil. Soil is accumulating forest carbon over time. The big one that I want us to think about is the vegetation itself, right? We're thinking about the trees and the shrubs that are growing in this forest. And as you can see with age, actually, young forest, if we were to fill it in from age 0, it would go up exponentially, and it would peak about 20, 25 years, and then it would just gradually decline, right? So we have that flush of new growth right away in a young forest, and we really reach our peak for carbon sequestration around 25 years. What's interesting to see here is that unlike soil and unlike the leaf litter and unlike even the total ecosystem sink itself, at some point, it actually becomes negative. So the forest at some point will no longer, the vegetation, at least I should say, not the forest vegetation at some point will not be sequestering more carbon. And that happens at about 125 years old. So I think that's important to highlight. And we can see that shift in sequestration rates in figure D here, right, with the overall forest ecosystem as a carbon sink. So it's interesting to see, right? It's interesting to see that whenever we are thinking about young forests, the role that they can play in sequestering carbon, storing that carbon then into leaf litter, and then eventually leaf litter into soil. So when trees are cut and manufactured into wood products, this is like an anthropogenic version of carbon storage. The carbon in some wood products can actually store carbon much longer than a tree would live. I have an example like, my grandfather has a barn, and it's actually made out of American chestnut. I don't know how many of you know the background of American chestnut, but that barn was built a long time ago in the 1940s when chestnut was becoming very, very rare. And since then, we have not actually had chestnut as its historic ecological niche that it used to fill because of chestnut blight. But yet, that wood, with all that carbon that's stored in that vegetation, after all these years, that carbon is still stored there. So, again, the carbon, it depends on some of the wood products, but it can sometimes store the carbon much longer than the tree would live. For less long-lived forest products, such as pulpwood or pellets, they offer sustainably sourced materials and have more favorable carbon balances compared to petroleum-based products such as plastics, oil, different fossil fuels. So sustainable forest sourcing is something we emphasize in the forest program at Audubon Mid-Atlantic. And actually, we even have events for folks at centers to help people identify what has been sustainably sourced. We want to make sure that if they are buying products and they're thinking about, forest carbon, or they're thinking about bird habitat, that this was done not in an exploitative way, but it was done to create bird habitat. So taking a tree, having it made into a product, we want to make sure that there's other trees, that there's young forest coming back, sequestering carbon, providing that habitat, rather than just set it and forget it. So we help people identify these products and materials to make a difference and a potential positive impact for forest birds. In fact, I was just on a field tour. It was Friday up in the Poconos and state game lands, and the Pennsylvania Game Commission was actually emphasizing the need for having young forests, putting young forests back onto the landscape. And they were doing so, they were talking about that from a wildlife, from an avian perspective, but they were also thinking of it from a climate resilient perspective. So forests that are on a landscape level, diverse in age class, they're diverse in structure and species composition, right? So young forests even have different vegetation communities, which is why they have different avian communities. That if you want something to be climate resilient, if you want our landscape to be climate resilient, we seek to accomplish this through forest management to attain our goals. This presentation on the importance of young forest habitat and the juxtaposition of having varying age classes, I should add, that again is something that we emphasize, and we love to hear different organizations and agencies kind of highlight that as well. So in a little bit of talk about, forests as carbon sinks and storage and things like that, and bird habitat, creating young forest habitat, you might be wondering, why haven't I heard anything about carbon markets? So what about carbon markets? There certainly are all the buzz these days. They're, at least in the forestry world, you hear a lot about it. But you also hear about in the news, and where does Audubon Mid-Atlantic stand on a market-based approach solution? Because we do not, as of today, endorse any carbon market program. So there are a couple around. So these are the ones that are at least found in Pennsylvania. I think that this has been expanded here recently. I do believe there are new programs, but these are the forest carbon programs, and NCX was actually discontinued. They had a lot of bugs that they were trying to work out, and to the best of my knowledge, they're not taking new customers. It has not been restored, but you've probably heard of the Family Forest Carbon Program. That's under the American Forest Foundation. It's practice-based. It has a 30-acre minimum. And though it used to have funding to treat competing vegetation, something we would be very interested in when we want to think about young forest, that has since been discontinued. So what we have left over here is what's called the growing mature forest, and funding. It's basically funding to limit harvesting over 25% of basal area. They don't want you harvesting a lot of big trees at the end of the day. They want to have that above ground live vegetation carbon store. And that's for 20 years. These are 20-year contracts. So that's what's around. We have worked cooperatively with the Family Forest Program. But again, I think that it's new. It's something we're still trying to wrap our heads around, what niche it can play with Audubon, with forest birds, and how things can get along. I mean, after all, you see down here on their website they have a cerulean warbler. So obviously they're not just thinking about carbon; they're thinking about birds as well, and that's really cool. But there are some things that I did want to highlight, and I guess I shouldn't even say multiple things for the interest in time. I wanted to highlight one example that's kind of giving us a little bit of hesitation in jumping in with these programs and going full bore on market-based solutions. And I call this a tale of two industrial companies. So according to the EPA, since 2005, the United States has declined its annual carbon emissions by 20%. This, probably surprising to most folks, hasn't been done through solar. It hasn't been done through electric. It has been accomplished by increasing, vehicle fuel efficiency. It's been accomplished through the use of natural gas for heating and energy production, and product and industrial efficiency. And that's a big one that I want to talk about with product and industrial efficiency. So here I display a recreated diagram. I'm not going to take credit for this or these ideas. This diagram is actually from Dr. Mark McDill from Penn State University, who presented on this in the spring. I was fortunate enough to catch his talk, and it was eye-opening. And again, it kind of gave us some things to think about whenever we're thinking about carbon programs. So I did not use his exact graph, since the research that is being conducted has not yet been published. But here, I can tell the story. So we have two companies. We have company A and B. And company A and B make the same exact product, let's imagine, and they make the same exact quantity of that product. But as you can see on the bottom here, we have the total CO2 emitted annually. We can think about it as tonnage or something like that. But again, the bars are just kind of a visual display. So they make the same product, make the same quantity. The difference is that company A, they're emitting more carbon to do it. So let's say that, and this is true of the United States, and it's true of many European countries as well. Let's say the US emission cap is there. It's that dotted red line. And boy, if you're over that, you're going to start paying fines, because we're worried about atmospheric carbon. So company B, right over here, they're pretty good. They fall underneath that. So they're not paying fines. They're able to make their product at that quantity, and they don't really have to worry about much. Company A, on the other hand, they're looking at pretty lofty fines. So really, they have two solutions to this problem if they don't want to pay the fine, right? They either become more efficient as an industrial company, right? That goes back to the product and industrial efficiency. Or what we now have with these carbon credit companies is they can buy carbon offset credits. And when they go to do their carbon accounting, you can see, their new line is now down here. So if they go and they buy some of these carbon credits, some of the carbon in the forest, they can fall below the emission cap. So they're getting fined. So I think it's fair to say, we still don't entirely know what to make of carbon credits and the impacts they're going to have on decision making by companies. Because if you're company B and you're seeing that company A is making the same product at the same quantity, but they are able to buy carbon credits to stay under, they're still emitting the same amount, they're still polluting the same amount, but they fall under that. What do you think company B is going to do? Does that incentivize company B to be more efficient, or does it incentivize them to emit more and then just pay offsets? So, I don't, again, they've called it a ticket to pollute. This is starting to hit academia, and I know Penn State is shifting their ideas on some of these things. But again, I think that for Audubon Mid-Atlantic, I wanted to mention it. I know it's out there. We're still kind of assessing where we want to be as far as having landowners enroll in that. And again, these impacts on society, and probably most importantly, what impacts will they have, on atmospheric carbon? What impacts might they have on forest over time are yet to be parsed out. So in the hopes that I did not go too much all over the place, I hope I hit on a couple different things. I will now take questions. I thank you for your patience. And, I hope I have questions, and I'm going to end the slideshow, but I will come back to that if there are certain slides you want to see. For those of you who are not staying, thank you for joining. But yeah, I would like to take some questions at this time. And
thanks a lot there, Josh.
Yeah.
So I actually have a question, and then I think
Yes.
anybody else who has a question can drop it in the chat if that works for you.
Okay.
So so you said that you had the wood thrush and the golden wing warbler, and they use mature and
Yes.
young forest. How, like you say, they have to be close. I mean, is a mile close? Is 5 miles close? It's close.
That's a great question, and I'm going to tell you, it probably depends on the species, right? So if it's a golden wing warbler, I know that there are programs out there that they try to get it within about 1.1 mile. So if I have young forest habitat here within a radius of about 1.1 mile, there's research to support that. I also know if we're talking about the Pennsylvania state bird that is struggling mightily, the ruffed grouse, that distance is much, much shorter. They want things like within a quarter mile. So
Okay.
it really depends on scale. It depends on kind of the species or maybe the communities that you're trying to target. That's a great question, Jane.
Yeah, that's interesting.
The size of the young forest also changes too. Some species, a 2-acre patch is all they need of young forest, and other species they want 10 plus. So
okay. As I've already stated, I'm not the best at this, so let's see if we have anything in the chat. Looks like, let me see here.
okay, so I see I can probably start taking some questions, Jane.
Okay, good.
So how do you determine where to create, this is from Hannah clip, how do you determine where to create young forest habitat, and is there a certain forest type that you would target when creating young forest? Another great question, Hannah. There are forest types that, if I'm being honest, they're a little bit more conducive, or they're a little bit easier to regenerate or push back into that pioneer community. I'll just use an example of like aspen, right? Big tooth aspen. They're pretty easy to work with if you had a stand of, aspen, and some of our oaks on a dry site, because aspen, whenever you cut them, whenever you go to create that habitat, they actually root sucker. So they reproduce very well. So there are plants and tree species, within that, plants, trees, shrubs, forbs, that are very much adapted to disturbance, that whenever there is a disturbance, they proliferate, they do well. Those communities are easy to work in than more climax communities, more shade tolerant species, that really, creating young forest habitat in those areas, you can do it. It's certainly possible, but it's a little bit more of a challenge. So that's a great question. I have one from Vicky Shears. Won't companies do what is cheapest on carbon emissions? There is a cost to becoming more efficient for whatever reason. The cost of the fines or the cost of buying credits. It doesn't really make sense that a company that is already efficient in the short term would become less efficient, but over time, as equipment ages, that could change. Yeah, so I think that from a hypothetical standpoint, it would depend on you're exactly right, Vicky. It depends on where's the fine at and where's the offset and what is cheapest, because you picked it, you hit the nail on the head with these companies that are buying these credits. They are going to do the cheapest route. I mean, they're trying to make a profit. I'm not saying that that's a bad thing, but they are going to take whatever is cheaper, whether that's paying a fine or credits. I know that for Mark, for McDill, for some of the concerns that we might have a little bit about carbon markets is, in the past, if you didn't have that as an alternative, you probably would just have to rear it back. You would have to pollute less. You would have to emit less. And that might not be the case. That might not be the case in the short term. So, forests are absolutely carbon sinks. I don't think anybody's going to deny that. We certainly won't. We know that it is storing and sequestering carbon. But from a wildlife habitat perspective and thinking about just the overall health or climate change itself, we're still trying to tease out what impact these carbon markets might have. I'm sure they're having positive impacts too. They might be having negative impacts, but we want to kind of wait and see what that balance is before we formally endorse said projects. And like I said, I know several folks of the American Forest Foundation, the Family Forest Carbon Program, and the folks that work there. I think they want to take more of a wildlife angle to things at some point, and they've kind of tapped on our shoulder to help them do that. So I hope things continue to evolve on that front. So thank you, Trish. Appreciate that. And yes, thank you to everybody else that either had to run and said it was great. I appreciate that feedback. Thank you, Amy. So from Ryan, if I mispronounced your last name or something, I apologize. Thomasin. There are a number of things that trouble me with managing mature forests for young forest habitat, reducing heat sinks, reducing water sinks, increased runoff and erosion, increasing invasive species, all trade off overall forest and health for species diversity. Every place I see management happening, I see native plants with stiltgrass, privet, ailanthus, garlic mustard, etc., which I'm already seeing reducing numbers, species of some moths, absolutely, because they're invasive. They don't host near as much of a caterpillar community. This continually, to me, feels like attempting to increase diversity at the expense of overall health. Thoughts? Well, Ryan, that is a loaded question. And I would probably start off by saying that there are certainly some things that you point out that I have observed or I have witnessed. I think that it's important to parse out the difference between forest management. I got the name right. Thank you. Forest management and harvesting. So in Pennsylvania, you don't have to be a forester to write forest management plans. You don't have to have a degree in forestry to be a logger or to work in the forest. And that's kind of concerning. So and I know that in West Virginia, to some extent, there's more regulation, but there's still a lot that goes on. There's a lot of harvesting. There's a lot of timber harvesting that's done for exploitive purposes. If we're talking about forest management, whenever I talk to somebody about forest management, the first thing that comes to my mind is really not harvesting trees. It's normally what kind of diversity do we have and what invasive plants are there? What invasive plants, what other existential threats? Maybe we have invasive pests, maybe we have different disturbances. And those are things that I want to take care of right away. So I consider sustainable forest management to be whenever you're done with your project, it's not filled with Japanese stiltgrass. It's not filled with European privet. because as I talked about a little bit towards the beginning of this answer, those are not supporting the cast of insects that we need, especially for forest birds that are insectivores during most of the season while they're here, especially the migrants. So I don't consider that management. Now, I think that, things happen, things get away from folks, but, you got to do re-entries into some of those stands. So as for mature, I guess I would say, how would you define mature? Is a mature forest 70 years old? Is it 110 years old? Is it 130 plus years old? Because as I was showing on that diagram that had the bell-shaped curve, where the distribution was very focused towards 70 to 110 years, I could have equally had a talk on the importance and the lack thereof mature forest. In fact, I just had a field tour at Dan's Mountain in Maryland. You might know where that's at in Western Maryland. And it was all about mature forest and how we need to have more of that on the landscape. So I'm absolutely with you. There are plenty of forests that are either through buffers or have been set aside to become mature forests. That talk that I just went on with the PA Game Commission up in Game Lands, I can't remember the number. There's so many of them in Pennsylvania, but it's in Pike County. They estimated that about 36% of their forest, about 30,000 acres, would never be managed forest. So that's going to be a good chunk of mature forest at some point. So I hope that answered some of your questions. I know there were multiple there. So got the name right. Well, I don't know. Unmanaged forests, a lot of times they're climax species. They're not including pioneer species. You're not finding aspen. You're not finding early successional species there. There are a lot of native flowering plants. There are a lot of native forbs. There are a lot of native trees that actually need to have disturbance. They have to be in young forest or you don't have them. Black locust is a good example of that as well. Okay, any other questions? Yes, I mean, that's the big thing. I'm not, I didn't come in here today, hopefully saying that we need to clear cut large swaths of the Mid-Atlantic, but we need to just be cognizant of having different mosaics, different communities. And yeah, I think that, invasive plants, invasive insects are certainly something, they're stressors we need to think about. But if you're doing things the right way, if you're doing things with sustainable management, you don't have those in large quantities. Absolutely. So
I have another question, and
yeah, Jane,
I'm able to unmute myself.
there you go.
How do you, what is a private owner's motivation if it isn't harvest, to make a young forest? So how do you educate the private landowner to make this shift in their landscape?
Yeah. So whether it's making young forest, preserving forest, or making mature forest attributes, I've been surprised, I think, since joining Audubon, how many folks are willing to do things for wildlife that might not even be commercial, as long as they're at least able to offset some of that non-commerciality. I've been surprised how many folks are interested in removing invasive plants once they can identify them. How interested folks are in the decline of some of these bird species. And, I used to see whippoorwills, but now I don't see them. They need young forest. I used to have ruffed grouse. We don't have them anymore. You don't have young forest. So I think from that angle, at least a lot of the folks that I've spoken with, that they truly do have an interest in wildlife. Now, don't get me wrong. There's there's people that say, yeah, I'm glad it's good for American woodcock, but I'm a deer hunter. So, I like to have that habitat type for deer because they take cover, or turkeys or bear or whatever. So, I don't know if it's ever just maybe one thing, but I've been pleasantly surprised, at least with the folks that reach out, how interested people are in forest birds and managing for their habitat. So Any other questions from me?
Well, it looks like no more questions coming in through the chat. And I'd like you, thank you very much. This was really interesting. And so I also apologize that I didn't start recording as soon as I should have. But, sorry about that. So so I think we'll go ahead and let you go. And thank you very, very much for
Yeah, well,
speaking
thank
to us
you.
tonight. So good luck with all your projects.
Thank you. Yes, I got many projects going on. This one's focused on young forests. Like I said, I got stuff for mature forests. I got stuff for everything. So tune in, look me up, and I got plenty of webinars out there. So,
Okay.
all
All
right.
right. Thank you for everyone for joining us. All right. Bye-bye.
Thank you all.